Okay, everyone, assalamu alaikum. Let's begin then. So we were doing functions and we were done with all the concepts that we had in this topic. Today, we are going to look at any remaining problems that you may have from the worksheet, or otherwise, if you've attempted any other recent past papers, you can let me know if there were any problems from there as well. That's the plan for today. So let me know. Functions worksheet, any problems? We will start with those questions. How many of you have attempted at least 20 questions from the worksheet, from the functions worksheet? At least 20 questions from the functions worksheet? Okay. What about the rest of you? What about the rest of you? Okay, so let me know if there were any problems then. Let me know if there were any problems. And we will start with them one by one then, inshallah. Yeah, so can you be specific? Which question specifically? Which question specifically? Okay, so let's get started. Let's start with this one. Let's start with this one. Question number one from the worksheet. Let's have a look at this. Question number one from the worksheet. Let's try this. Okay, so we've got two functions f and g. They are defined like this. F of x equals this and g of x equals this. F of x is defined for x not equal to 1 over 2. So apart from 1 over 2, you can have any value of x. And g of x is defined as x squared plus 4, and it's defined for all real values. Okay, that's what we're given. Now the diagram shows part of the graph of f of x. We need to state the domain of f inverse. Domain of f inverse. Okay, how do you figure out the domain of f inverse? Domain of the inverse function. What is that equivalent to? Domain of f inverse is the same thing as the range of f, the range of the original function. So if we can somehow find the range of the original function, that will be the same as the domain of the inverse function, right? So what's the range of f of x? How do we think about this? It's a reciprocal function. Generally, we said if we have a reciprocal function, we looked at the method for finding range for that, right? We said we would not need to draw the graph for this ourselves. It's not part of our syllabus to be able to draw graphs of reciprocal functions. So we said if it comes, they will give you a domain like this in which you'll look at the endpoint, see what happens at the endpoints, and based on that, you can write down the range. Except if they give you a graph themselves, and that's the case that we have here. They have given us a graph in the question themselves. So we can just look at the graph and see what the range is going to be. So looking at the graph, remember what range represents. Range represents possible y values. Possible values of y that you can get as an output from this function. Look at the graph. What are the possible y values? What are the possible y values? -3 to 4. Okay, -3 to 4. Okay, that's what it looks like. But what does the question say? The diagram shows part of the graph. It's not complete graph. It's not complete graph of this function. It only shows part of the graph. Okay. Now, you've seen graphs of reciprocal functions, right? They extend up to infinity. So these are basically asymptotes. So if you were to extend this function, it will go up like this. It keeps going on like this in the upwards direction. Similarly, in the downward direction as well, it goes down like this. So it's just part of the graph. It doesn't mean that the lowest point is -3 and the maximum point, the highest point is 4. That's not what it means. Similarly, on the left side as well, this graph extends like this. It makes an asymptote here. And on the right as well, it extends like this. It becomes an asymptote here. Now look at this graph. Once you have extended it like this, look at the graph and see what are the possible y values. So in the upwards direction, the graph can go as far up as possible. In the downward direction as well, the graph can go as down as much in the downward direction as possible. So it could go to positive infinity, it could go to negative infinity. Is there any y value that is not possible? Is there any y value looking at this graph that is not possible? 1, right? So if you look at 1, this point, the graph never equals y equals 1. The graph does not touch this line. So on the right side as well, it's becoming an asymptote like this. On the left side as well, it's becoming an asymptote. So it's not touching the line y equals 1. So the y value can never be equal to 1 in this case. So that's what we write as the range. We say the range of f of x, the range of the function f, this is y not equal to 1. That's the range of this function. Okay. Now, if that's the range of the function, what about the domain of f inverse, domain of the inverse function? That must also be not equal to 1. But since we're talking about domain there, domain is supposed to be x values. So we say x is not equal to 1. That's what you write there. X is not equal to 1. That's your final answer. Is that all right? Okay, that's actually correct. Another way to write this could be, so this is one possible answer. You could also say the range is y less than 1 or y greater than 1. And then the domain would become either x less than 1 or x greater than 1. That could be another possibility. There would be an or between them, right? Either this or this. You could also do that. Okay. That was the first part. The other parts are fairly straightforward, but let's just complete them as well. Part B. In the second part, it says find an expression for f inverse of x. We've got function f, right? That's 2x plus 1 over 2x minus 1. Let's write that down here. F of x equals 2x plus 1 over 2x minus 1. The domain was given to be x not equal to 1 over 2, right? Let's find an expression for f inverse. That will be your standard process. How do we start? We say let y equals f of x, and that becomes y equals 2x plus 1 over 2x minus 1. Now you just need to make x the subject. How do you do that? Multiply this on the other side, and that will give you 2xy minus y equals 2x plus 1. Take all x terms to one side. 2xy minus 2x on the other side, you've got y plus 1. Take x common, and that leaves you with 2y minus 2 inside, and that goes to the other side and becomes x equals y plus 1 divided by 2y minus 2. Now you can write this down in inverse function form. F inverse of x is therefore equal to x plus 1 over 2x minus 2, and that's the final answer. That was the second part, fairly straightforward. This is all that you had to do there. Is that okay? Part B. Now it says find gf inverse of 3. Gf inverse of 3. We've already found the function f inverse. What about gf inverse? What was the g function? G function was x squared plus 4. Right? G is x squared plus 4. G of x is x squared plus 4. X is true for all real values. Can we find gf inverse first of all? Gf inverse of x, what would that be? That means inside the function g input f inverse. So that becomes g of f inverse. That means x plus 1 over 2x minus 2. All you have to do is inside the function g, you input this in place of x, and that becomes x plus 1 over 2x minus 2 whole squared plus 4. Now they wanted you to figure out the value for gf inverse of 3, right? Gf inverse of 3. That's what they're looking for. You just input that value of x inside this. It becomes 3 plus 1 divided by 2 into 3 minus 2 whole squared plus 4. And you can see what this turns out to be. In the numerator, you've got 4. In the denominator as well, you've got 4. So that's a 1. 1 squared plus 4. That will be 1 plus 4, which is 5. That's the value that we were looking for, right? That's part C. Again, fairly straightforward. This is what we had to do in this. Okay, so we found the function gf inverse, and then we just input 3 in that in place of x. Achha. Then the last part says, explain why g inverse of x cannot be found. Now, without even looking at the function, you know the answer to this question, right? Why can an inverse not exist for any function? Because it's not one-to-one, right? And you can see here as well, it's a quadratic function. Quadratic function defined for all real values. It will be a U-shaped graph like this. It fails the horizontal line test. I can draw this horizontal line that cuts the graph at 2 points. So it's not one-to-one. All you have to write down here is, you would say, it's not a one-to-one function. So g of x is not a one-to-one function. That is why the inverse does not exist. That's a standard answer for such problems. Whenever an inverse does not exist, the only reason for that is that it's not a one-to-one function, right? That's what right there. Is that okay? Achha, any other problems? Any other problems from the worksheet or otherwise from the recent papers? Why do I feel you haven't done a lot of practice? Because there were quite a few difficult questions, both in the worksheet and otherwise in recent papers. Yes, other questions from the functions worksheet. Okay, question number 9. Let's have a look at this. Question number 9 from the worksheet. Let's try this. Question 9. Let's have a look at this next. Okay, so it says functions f and g are defined. Yeah, sure, you can do that. Or you can just tell me the paper number if you have that. So I can copy from there. Functions f and g are defined as follows. F of x is x minus 2. That's okay. F of x is equal to x minus 2 whole squared minus 4 for x greater than equal to 2, where a is a constant, and g of x is defined like this. State the range of f first of all. Okay, it's a quadratic function. It's a quadratic function that looks like this. F of x equals x minus 2 whole squared minus 4. The domain of this function is x greater than or equal to 2. That's the domain of this function. How do you figure out the range of the function? How do you figure out the range of the function? Remember, we always have to think of the graph. It's already completed square form, right? It's already completed square form. We can figure out the turning point from this. What's the turning point going to be? It's 2 and negative 4, right? So it's a U-shaped graph. It's going to look like this. That's what the graph looks like roughly. U-shaped like this. The turning point of this graph, is 2 and negative 4 from this completed square form. X minus 2 equal to 0, that gives you x equal to 2. And this number outside that represents the y coordinate. This is the turning point, 2 and minus 4. Now, what's the domain of the function? The domain of the function is x greater than or equal to 2. So what part of this function are we considering? We are considering this part of the function that I've highlighted. What's the range of this part? The lowest point is negative 4, and you can be anywhere above this, right? So what will be the range in this case? The range is going to be y greater than or equal to negative 4. Yeah, so that's the range. So that was pretty straightforward, first part. Second part, again, standard f inverse. How do you find f inverse of a quadratic function? Let's do that. In the second part, they say find f inverse of x. F of x equals x minus 2 whole squared minus 4. The domain of the function is x greater than or equal to 2. Yeah, so it's not that difficult, right? It's not that difficult. Okay, let's try this. To find inverse of a quadratic function, we first need to complete the square. The square is already completed in this case. So we can just make x the subject. We start like this. First of all, we say let y equals f of x, and then it becomes y equals x minus 2 whole squared minus 4. Now make x the subject. You take that to the other side. So it becomes y plus 4 equals x minus 2 whole squared. Take square root on both sides, and that gives you x minus 2 equals, I'm writing this term on the left side, this on the right. Doesn't make any difference, right? So I take square root on both sides. That gives you x minus 2 equals plus minus square root of y plus 4. Now take 2 to the other side, and that becomes 2 plus minus square root of y plus 4, right? How do we decide between plus and minus now? How do we decide between plus and minus? How do we decide between plus and minus? Should we use plus here or minus here? Remember the process? We look at the domain, right? The domain of this function was x greater than or equal to 2. Let's write that down here. So we were given that x is greater than or equal to 2. Now, if x is greater than or equal to 2, can we get a value greater than 2 with 2 plus something or 2 minus something? So it'll have to be 2 plus something. So we use plus sign here. We use plus sign here. And the final result, therefore, is going to be f inverse of x equals 2 plus square root of x plus 4. And that's our final result. Okay, that's part B of this. So you always write plus minus there, first of all. You always write plus minus. And then you decide between them using the given domain generally. Right? That's what you do in this case. Let's look at the next one. Part C. Now it says, given that a is equal to minus 5 over 3, solve this equation. F of x equals g of x, the value of a is given. Okay, let's try this. A equals minus 5 over 3. F of x is equal to x minus 2 whole squared minus 4. That's the function f of x. The domain of this function was x greater than equal to 2. There was another function g of x, and that was ax plus 2. And that is defined for all real values. We are given in this part that the value of a is negative 5 over 3. Value of a is negative 5 over 3. So it becomes, g of x becomes negative 5 over 3x plus 2. We need to solve this equation f of x equals g of x. Now all we have to do is equate both of them, f of x and g of x, equate them. What do you get from that? X minus 2 whole squared minus 4, that equals minus 5 over 3x plus 2. How do we solve this quadratic now? We can expand the left hand side, and that becomes x squared minus 4x plus 4 minus 4 equals minus 5 over 3x plus 2 on the other side. Plus 4 and minus 4 get cancelled. You can multiply this 3 on the other side. And that becomes 3x squared minus 12x equals minus 5x. But remember, when we multiply by 3, 3 is also going to get multiplied by 2, right? So minus 5x plus 6. So I've multiplied the whole equation by 3 to get rid of the fraction. Now that becomes 7x. Now, if I take all terms to one side, that'll become 3x squared minus 7x minus 6 equal to 0. Can we factorize this? 3 times 6 is 18. We can use 9 and 2, right? 3x squared minus 9x plus 2x minus 6 equals 0. We get two factors from this, 3x plus 2 and x minus 3. It's necessary to show this working. You cannot write down the answers directly. You either show the factorization process or input values in the quadratic formula. One of these two things is necessary, otherwise you don't get marks. Okay. Now you get two values of x from this. X equals minus 2 over 3 and x equals 3. That's your final answer. Is this your final answer? Do we leave it like this? Whenever you get multiple answers, you should always check, can we have multiple answers? Does the question say anything? the question just says solve this equation. Okay, so that's not clear enough. We could have single solution, we could have multiple solutions. But what do you think? Are both of these solutions possible? Is there any restriction in the question because of which we may have to ignore one of those solutions? There is a condition, right? So we are using f of x equals g of x. So both the conditions for f and g, they have to be met, right? Condition for both f and g, they have to be met. Condition for f is that x is greater than or equal to 2. X is greater than or equal to 2. Now this first value does not satisfy that condition. So we have to ignore this answer and we say the only possible answer is x equals 3. Okay. If you leave both the answers, you lose 1 mark. Okay. After all that work, you would only get 2 out of 3 marks if you don't cross that out. Okay. That's the only answer then. X equals 3. All right. Let's have a look at the next part now. Part D. Part D. Now it says given instead that GF inverse of 12 is equal to 62. Find the possible values of A. Okay, how do we think about this? GF inverse of 12 is equal to 62. Now, an important point, you see the function is GF inverse, right? In this question, they have made us find f inverse in a previous part already. So we can use that. We have already found f inverse. If we had not found f inverse earlier and they gave us something like this, in this case, finding f inverse is a pretty long process, right? It's a quadratic function. So finding inverse is a pretty long process. A more efficient method in that case would have been that you take this f inverse to the other side in a way. What does that become? When it goes to the other side, it becomes f. So this equation we could write as g of 12 equals f of 62. And that way we would not have had to find f inverse. Okay, we could solve this equation. In this case, however, since we have already found inverse in a previous part, so we can just use that. We can use that inverse. GF inverse of 12. Let me write that down here. GF inverse of 12. They're saying this is equal to 62. This is equal to 62. Find the possible values of A. Now, what's the function g of x? G of x function is ax plus 2, x being all real values. And inverse function that we found was this. And this is the inverse function. Let's write that down here as well. This is the inverse function. Okay. Let's do it step by step. F inverse of 12. Can we just find that first? We can do this separately as well. That will be easier. 2 plus square root of 12 plus 4. What do we get from that? Square root of 16. What's that going to be? 4. So that's 2 plus 4 and that is 6. So f inverse of 12 is equal to 6. Okay. What that becomes is g of 6 equal to 62. Okay. Now let's evaluate this. We introduce another bracket here. To simplify this, we can now say g of x. Let's evaluate g of x. What would that be? G of x, input g of 6, sorry, input 6 in place of x there. And that will become 6a plus 2, that equals 62. And now g of 6a plus 2, now input 6a plus 2 in place of x. And that becomes a into 6a plus 2 plus 2 outside as well equals 62. And that's the equation that you can now solve. It's a quadratic equation again. 6a squared plus 2a plus 2 minus 62, that will become minus 60 equal to 0. We can simplify this by dividing it by 2. 3a squared plus a minus 30 equal to 0. 3 times 30 is 90. 10 times 9 is 90 as well, right? So we can say 3a squared plus 10a minus 9a minus 30 equal to 0. Alternatively, you could input values in the quadratic formula, and that's also fine. You get a common from the first two terms and then minus 3 common from the next two terms, and that leaves you with 3a minus 10 inside, and we get two possible values of a. One possible value is 3 and the other possible value is 10 over 3. Now the question says find the possible values of a. So that tells you there are going to be multiple values. There are going to be multiple values. Did I make an error somewhere? 30a squared, that was 30a squared. Where did I multiply by 10? Okay, so what I've done is, we're fine until this point, right? 6a squared plus 2a minus 60 equal to 0. I just divided it by 2 at this point, just to make the number smaller. So that became this. Then I've broken the middle term. I've not multiplied by 10. I'm factorizing, right? I've broken the middle term a to 10a minus 10, 9a. I've just done factorization. Okay, we get two possible values of a. One is 3 and the other is 10 over 3. One is 3 and the other is 10 over 3. The question said find the possible values of a. We are getting two answers, so both of them are going to be acceptable, and that's our final answer. We leave it as it is. Okay. Makes sense. Let's try another. Any other question? Any other questions? England lost. Score इतना ज़्यादा कर लिया था उन्होंने. Oh, they got so close. Wow. Bumrah saved them again. That 18th over. Okay. Question 25. Question number 25. Let's have a look at this. Question number 25. Question 25. Which part? First part? Okay. Let's just do the first part of this, and then let me know if there's any other question as well after this. Let's just focus on the first part. The other two parts are straightforward, right? Let's do the first part of this. Question 25. Sure, let's try this. Okay. It says the function f is defined by f of x equals 48 over x minus 1 for x between 3 and 7. That's the function. We are given the domain of the function. The function g is defined by g of x equals 2x minus 4 for x between a and b. Find the greatest value of a and the least value of b, which will permit the formation of the composite function gf. Okay, composite function gf. Remember the condition that we have for composite functions? What's the condition for being able to form a composite function? Let me write that down here. The whole range of the inner function must be part of the domain of the outer function, right? That's the condition. Range of inner, domain of outer, they must be connected, right? Now, what's the inner function in this? When you have gf, the inner function is f, right? The one that comes after. And the outer function is the one that comes first, that's g. Outer function is g, inner function is f. Now, they must correspond to each other for the composite function to be formed. Okay. Now, do we know any of these things? Do we know the domain of g or the range of f? Do we know any of these things? Domain of g or range of f. Domain of g is given to be this, right? X between a and b. Let's write that down here. X between a and b. Range of f. Can we figure that out? We can figure that out. We are given the domain. It's going from 3 to 7. We can input values. It's a reciprocal function, right? In reciprocal functions, we just look at the endpoints. What happens at the endpoints? We would input 3 and we would input 7, and that will give us the range. We don't even need to sketch graphs for reciprocal functions. If we need the graph, they will give us the graph in the question. Okay? If we need the graph, they will give us the graph. In this case, they have not given the graph, so we can just input the endpoints and that's going to be sufficient. Let's do that. Range of the inner function, let's figure this out. F of x, that is equal to 48 over x minus 1. The domain of the function is x between 3 and 7, right? That's the domain. You can input 3 and see what happens at that. When you input 3, what do you get? 48 over 2, that's 24, right? F of 3 is 24. And then you input 7. What's f of 7? 48 over 6, that will be 8, right? So you're getting 24 and 8. So range of f, therefore, what is that going to be? It's going to be between these two numbers, between 8 and 24. That's the range, right? Between 8 and 24. Okay, now the range of f is therefore 8 to 24. That's the range. So now we can write down those values, right? Possible values of a and b. We can say the greatest value of a that they're talking about, we compare them, right? That's 8 here. And this value should be 24 here. So the values that they're asking about, greatest possible value of a, that is going to be 8, and the least possible value of b that they're talking about, that is going to be 24. That's what you write down there. Okay, if a was any bigger than this, for example, if a was 9, then we would not be able to input all of these values there, right? So that's why this is the greatest possible value of a. Otherwise, whole of this range cannot be input in that domain. So we just compare them. The value for a should be 8 and b should be 24. Is that okay? Any problems with this? Any problems? Last 2-3 years, they have some of the harder functions questions. So make sure that you practice recent papers as well. You're doing some of these questions that we're doing are from 2022. But 23 and 24, try those as well. They also have some good questions on functions. Make sure that you try them. Yeah, functions is the most difficult topic of paper one. It's definitely the most difficult paper one. It's transformations questions, specifically especially when they come with trigonometry. Sometimes they tend to be quite complicated. So it does require a lot of practice, a lot of practice. Okay, this was question number 25. Now let's have a look at another. Let's have a look at another. Okay, let's try this. This is question number else. Yeah, let's do this one first. Question number 6 from the worksheet. Let's try this. Question number 6. How many of you have done this? Question number 6 from the worksheet. This is one of the harder ones that you'll find in past papers. Were you able to do this? The first part, the second part, in fact, F inverse. Mashallah, skip kar diya aapne. And you're satisfied with that. You're not even asking about it. Okay. The diagram shows y equals f of x. The diagram shows y equals f of x. It says on this diagram, sketch the graph of y equals f inverse of x. When you're practicing, don't just skip the harder questions. Those are the questions that you should actually be attempting, right? So after you're done with the topic and you've done like 10, 15 questions, you should be looking for the harder questions, okay? And attempt all of them. So any question that you don't understand the first time you read it, that's the one you should definitely be attempting. Okay, that's really important. Sketch the graph of y equals f inverse of x. Now, how do we do this? Graph of f and f inverse, they're always reflection of each other in the line y equals x. So what we can do is we can draw a line y equals x. Y equals x line, we are not given any points here, right? So how do you draw that line y equals x? Y equals x line is a 45-degree line, right? So it should be almost a 45-degree line like this, passing through the origin. This is the line y equals x. You are given f of x graph, right? This is f of x graph. What you need to find out is, what you need to sketch is the graph of f inverse. Now, how do you do that? F and f inverse, they are reflection of each other. They're reflection of each other in the line y equals x. How do we do reflection? Perpendicular distance from the line of reflection, it should remain the same, right? On both sides. So take some points. So let's suppose this is f of x, right? Take one point on f of x. If I take this point, for instance, this point on top, where will it go after reflection? You'll put your scale and you will measure that, okay, this is the distance that you have on this side. Go the same distance on the other side and mark some point here. That point is going to go there. So this point that I marked there, that comes here. Okay, so mark one point like this. Then take another point on the graph. I'm taking this point. Where does this point go? Again, place a ruler. Whatever this distance is, go the same distance on the other side. And that point is going to come somewhere around here, maybe. Okay, so you've got 2 points on the inverse graph. What do we do now? We need some other points to be able to understand it better, right? So origin will remain there where it is. Let's take one point here, this point. Where does this go? This is going to go somewhere around here, right? And similarly, take this point. This goes somewhere around here. So you roughly mark those points and then you join them and you get that shape. So it looks something like this. You're going to have a curve that looks like this, right? So that's what the shape is going to be. The points are not accurate, so they're just for reference, right? But the shape is going to look like this. And that's your F inverse graph. This is what we had to draw. It's very hard to figure it out directly without taking points. So that's what I would recommend, that you take points like this and then you join those points. Okay, that's F inverse graph. Now it says it's now given that f of x is equal to this. Now they've given you the function f of x equal to this. And they're saying the domain of f is x between -2 and 2. We need to find an expression for f inverse of x. How do you find inverse of this function? Inverse of this function. How do you figure that out? Inverse of this function. Let's start with this. F of x equals minus x divided by square root of 4 minus x squared, right? That's the function f. The domain of this function is x between -2 and +2. That's the domain of the function. Now, how do you find inverse of any function? How do we start? We say let y equals f of x, and then it becomes y equals minus x divided by square root of 4 minus x squared. We need to make x the subject now, right? Now we've got x inside the square root here. To get rid of that square root, we can square both sides. We can square right now, or first multiply it on the other side and then square. Either of them is okay. If I square both sides right now, that gives me y squared equal to x squared divided by 4 minus x squared, right? This minus will get eliminated when we square something. The negative disappears, right? Now make x the subject, you multiply this on the other side, and that will give you 4y squared minus x squared y squared. That equals x squared. Take all x terms to one side. If I take them to the right, that gives me x squared plus x squared y squared. On the other side, I have 4y squared. And now I can take x squared common. That leaves me with 1 plus y squared inside. And we've got 4y squared on the other side. 1 plus y squared gets divided there. 4y squared divided by 1 plus y squared, that equals x squared. And now we take square root on both sides. I'm writing this x on the other side. X equals plus minus square root of 4y squared divided by 1 plus y squared. This is what we end up getting. Now, can we simplify this? This is 4y squared, right? Square root of 4, what's that? Square root of 4 is 2. We can write that outside. Square root of y squared, that is y. So we can write this as plus minus 2y divided by 1 plus y squared. This is what x turns out to be. Now at this point, remember, we needed to figure out whether to use plus here or minus here. Plus or minus. Do we use plus or minus? We look at the given domain, right? Okay, let's look at the domain. The domain is -2 to 2, right? That's the domain. Can we figure out whether to use plus here or minus here? There's a square root in the denominator. Do we use plus or minus? Does the domain help in this case? For quadratic functions, it always helps, right? But this is not a standard quadratic function. This is some other weird function. In this case, we could think of the domain, but that's not helpful because you have plus minus 2y. The domain has positive values as well. It has negative values as well. So we can't really be sure whether to use plus there or minus. Now we use our mind. How do we use that? We skip the question using our mind. Educated guess. Plus or minus. How do you figure this out? Plus y plus y plus. What will be the reason for that? We keep it as plus minus, but remember with plus minus, we can sometimes end up getting a many to one function, right? That's not acceptable. Look at the original function as well. You had a minus sign there. Look at the graph that they made you sketch there. Does the graph give you a hint? Does the graph give you a hint? Let me actually make the graph slightly better here. It's looking like a many to one function. It should not be a many to one function. It should be like this. G, what do you think? Looking at the graph, do we use plus or minus? Do we use plus or minus? If we were to write down the inverse function here, the inverse function would be f inverse of x equals plus minus 2x divided by square root of 1 plus x squared. Now let me just copy this here with the graph. Look at the graph and look at this function. Does the graph give you any hint about it? Does the graph give you any hint about it? X and y have opposite values. They have opposite signs. Look at the graph. Look at the graph. It's in the second quadrant and it's in the fourth quadrant. Now, do you know the values of x and y in these quadrants, whether they're positive or negative? On the left side, x is positive, and sorry, x is negative and y is positive. In the fourth quadrant, x is positive and y is negative. So in both of these quadrants, x and y have opposite signs. In both quadrants, x and y have opposite signs. What does that tell you? If we use plus here, then if x is positive, then plus into plus, it will remain positive. The y value will also turn out to be positive. But if we use negative here, in that case, if x is a positive value, then minus into plus, that will make it negative. The y value will turn out to be negative. And if x was a negative value, then negative into negative, it will become positive and the y value will turn out to be positive. So with negative sign, we would get a graph like this. With positive sign, the graph would be in the first and third quadrants. That's not what we want. In the original function as well, we have a negative sign there. That graph is also in the second and fourth quadrants, right? So if you were to draw this complete graph, now that's, you're not required to know this, but if you were to draw the complete graph with plus minus, it would look something like this. It will be like this and this. Right, this complete f inverse graph, it would look something like this. And that's clearly not one-to-one, right? That's not one-to-one. So we can't use plus minus. So we use minus here for that reason, looking at the graph. So the final inverse function, therefore, that is going to be minus 2x divided by square root of 1 plus x squared. So it's negative sign there, right? Because x and y have to be opposite. They need to have opposite signs. And that can only come with negative there. Okay. Achha, that was part B of this. Now the next part is also interesting. It says the function g is defined by g of x equal to 2x for x between negative a and positive a. Okay, negative a and positive a. State the maximum possible value of a for which fg can be formed. Maximum value of a for which fg can be formed. Okay, let me quickly repeat this. We used negative there because in both of these quadrants, x and y have opposite signs. In both of these quadrants, x and y have opposite signs. If x is negative, y is positive. If y is negative, x is positive. So that function was 2x divided by square root of 1 plus x squared, right? That we found there. Now, if we use a plus sign there, then x and y would have the same signs, right? If x is positive, this will always also be positive because you have a plus sign here. With negative, however, the sign will become opposite. With negative, the sign will become opposite. So if this was positive, then minus will make it negative and the y value will turn out to be negative. If x was negative, then this minus will make it positive and the y value will turn out to be positive. So we want that to have the opposite signs. That is why we use a negative sign with that inverse. Okay, that's the reasoning behind that. Okay, let's move on. Let's move on to the next part. Now it says the function g is defined by g of x equal to 2x. X is between negative a and a, where a is a constant. State the maximum possible value of a for which fg can be formed. Now, we have talked about this in the previous question as well. The condition for a composite function being formed, I'll do this on the right side. So we have that in front. Part 3, part C, in fact. Achha. So we are given g of x. We are given g of x. G of x is equal to 2x. The domain of this function is between negative a and positive a. All right. The function that we are forming is fg. What's the condition for the function fg being formed? What's the condition for the function fg being formed? Range of inner and domain of outer, right? Range of inner. What's the inner function in fg? What's the inner function in fg? G function, right? That's the inner function. This should correspond to domain of outer. Domain of outer. The domain of the outer function f. Do we know any of these things? Do we know the domain of f? Yes, we know the domain of f, right? Minus 2 to 2, that is given. So we know that this domain is from minus 2 to 2. All right. That means the range of g must also correspond to that. It must correspond to that. Can we find the range of g? It's a linear function. This is a linear function. What's the range of this function going to be? It's a straight line. Positive gradient. So it looks like this. The domain is from negative a to positive a, right? So I can take some point negative a here and another point positive a here. We are looking at this part of the graph from negative a to positive a. Okay? Negative a to positive a. What about the corresponding y values? If x is negative a, what about the y value? Corresponding to this, that's minus 2a. If x is a, the corresponding y value is 2a. So what's the range going to be then? The range is going to be from negative 2a to positive 2a. That's the range. Okay? Yes, minus 2a to 2a. That's the range. That's what the range is going to be. Y between negative 2a and positive 2a. And now we can compare them. They must correspond to each other, right? So if we compare, we can say minus 2a must correspond to minus 2 and 2a must correspond to 2. What's the value of a that we get from this? We can equate any of them. You can say 2a equals 2, for instance. The value of a turns out to be 1. They said greatest possible value of a, right? Maximum possible value of a. The maximum possible value of a is this. Why maximum? Because if a was any bigger than this, for example, if a was, I don't know, 3, what happens? You get minus 6 to 6 in this case. And that cannot be input here. So the maximum possible value of a can be 1. Maximum value of a can be 1. Because if a becomes greater than 1, this range that we have got is going to become bigger than this domain, and we would not be able to input that in that function f then. So that's the maximum possible value of a. All right, that's what we were looking for. That's part C. Okay, let's move on. That was part C. I'll just copy that there. Part C. Okay, last question. Last question. Assuming that fg can be formed, find and simplify an expression for fg of x. Now this is simpler. You have the function f of x. The function f of x is minus x over square root of 4 minus x squared. And you also have the function g of x. G of x is 2x. They want you to find fg of x. Right? That's pretty straightforward now. Fg of x. So inside the function f, you need to input g. So that becomes f of 2x. That's what you need to figure out. So it becomes minus 2x divided by square root of 4 minus 2x whole squared. Now that's the function fg of x. Now they have specified that you need to simplify this expression as well. So you cannot leave it like this. You cannot leave it like this. You have to simplify this further. How do we simplify this? Look at the denominator. The denominator is 4 minus 4x squared inside the square root. Can we simplify this further? Can we simplify this further? 2 minus 2x. Abdul Hadi, think again. We can't use indices rules here, right? This is minus. We can't put that power 1 over 2 on each of them separately. That doesn't work. So what we can do is we can take 4 common. We can take 4 common from the denominator. And that leaves us with 1 minus x squared inside. So we've got square root of this whole thing. In the numerator, we've got minus 2x. And now square root of 4, what's that? That's 2. We can write that outside. So it becomes minus 2x divided by 2 into square root of 1 minus x squared. And now 2 and 2 get cancelled. And you're left with minus x over square root of 1 minus x squared. And that's your final answer. This is what they were looking for. Yes, in the denominator, you could say 1 plus x into 1 minus x, but that's factorized form, right? Yeah, it is, but that will be factorized form, right? This is simplified form, so we just leave it as it is. Okay. That's the function fg of x. All right, I hope that was helpful. We are going to stop here for now. In the next P1 class that we have got, we will be doing function transformations. But now the schedule for P1, as I mentioned earlier as well, that's going to change. We are starting M1 and S1 course tomorrow, inshallah. Tomorrow at this time, at the time that we have our P1 and P3 classes right now, we are going to have M1 and S1 at this time. For the remaining P1 classes, so we're going to have 3 more classes on P1. In one of them, we're going to do function transformation questions, right? That's one class that we have to spend. We have done the concepts, right? Then in another, we're going to complete the AP-GP concept. That's a small topic. And then in another, we will do past paper questions on AP-GP. So 3 more P1 classes, but they will be on some other days now, right? So the current schedule for P1, P3, that's going to be replaced with M1 and S1, right? So we're going to have M1 9:50 to 10:50 or 10 to 11 roughly, S1 11 to 12:10, inshallah. Okay. The same days, Mondays, Tuesdays, Thursdays, Fridays. For the remaining P1 and P3 classes, around 3 classes for P1 and maybe 4 for P3, we will have to schedule them on other days. Yes, so tomorrow we have class on Friday, right? So we are starting tomorrow, Monday, Tuesday, Thursday, Friday. Yeah. So we start M1 and S1 tomorrow, inshallah. The remaining P1, P3 classes, we will be scheduling them most likely on the weekend, Saturday and Sunday. We need 3-4 more classes to do iteration in paper 3 and AP-GP in paper 1. Okay, these are the easier topics that we're left with. We will do them over the weekends, inshallah. Okay, that's it. I'll see you again in the next class then. Allah Hafiz.